Welcome, everyone. Thank you for joining today's webinar, How to Avoid the Pitfalls of Calibration System Implementation, co-hosted by ISA and BMEX. My name is Stacey Logan. I'm with ISA, and I'll be hosting today's webinar. Before we get started, I'd like to review just a few housekeeping items to let you know how you can participate in today's session. First, in regards to the Q&As, we will have two today, one Q&A within the presentation and another session at the end. If we are unable to get to your question during the midway Q&A, we will hold it until the final. To submit your questions, simply type them into the Q&A box in the lower right-hand side of your screen. If you have specific questions directly for me, the host, submit those into the chat box. If you are viewing with a group at your site, please designate a scribe to submit your questions. And unfortunately, with a large amount of pre-registrants, we can't open the phone lines for these questions. If we don't get a chance to respond to your questions, or if you would like to discuss a topic in more detail with one of the presenters, please feel free to contact them directly. That information will be given at the end of the webinar. Second, for those of you who have just joined, please make sure that you are on mute. Both your phone and computer microphones should be muted. If you'd like to see the phone and audio broadcast connection instructions again, please refer to the confirmation emails I sent you, or if you have the top left-hand side of your WebEx screen, you will see a tab labeled Meeting Info. Some of the connection instructions are included there as well. Now, I'd like to tell you a little bit about our presenters today. Chuck Boyd has been in software development, system implementation, and business development roles for the past 29 years. Chuck spent 10 years as a business system analyst on software development projects. In this role, he functioned as a communication conduit between the business and IT, working with key executives and users to translate business vision into process and data roles while identifying business roles and testing requirements. Chuck holds a Business of Science degree in Computer Information Systems from DeVry University of Technology. Today, Chuck manages BMEX key accounts as well as market development in the southeastern United States. Pekka Videnoja has been involved in software development and implementation for the past 14 years. He has managed calibration system implementations for the past 5 years, and prior to that, he managed and executed software development projects for about 9 years. He holds a Master of Engineering in Strategic Leadership of Technology-Based Business from Century University of Applied Sciences, and a Bachelor of Engineering in Information Technology from Old University of Applied Science. Today, Pekka manages the BMEX Professional Services team and provides technical support to BMEX customers and the sales team globally. Jody Damron has 36 years of experience in the electric utility industry at Salt River Project Generation. His past experience includes time as a control room operator, instrument technician, VCS technician, HVAC controls technician, instrument, electrical, maintenance, planning and scheduling, and apprentice supervisor. Jody was the business lead for many critical projects, including instrument data and software calibration upgrades, work and asset management software upgrades, control system upgrades, and many business process upgrades. He is the co-author of ISA 77.70.01, Tracking and Reporting of Instrument and Control Data, and serves as an ISA committee chairman. Today, Jody supports Salt River Project Generation as a business analyst liaison between generation and IT software applications. And now I'd like our first presenter, Chuck, to take it from here.
All right, thank you, Stacy, and welcome everybody. Good morning. Today we've got three presenters, and we will focus on each covering a certain topic. We'll cover the pitfalls of calibration system implementation, and so you can recognize some of the pitfalls and perhaps some ideas of avoiding them. Pekka Videnoja will go into a little bit more detail into a process methodology and steps to execute one of these projects. We'll open up the chat lines and take some questions, and then Jody will cover his project and his experience in a implementation case study. We'll open up the lines again and take some questions, and then we'll wrap it up. So the pitfalls of a calibration program. Let's just get right into it. First, let's establish some definitions here that will kind of lay the foundation for the rest of the agenda today. Calibration, it's this process we use to maintain an instrument's accuracy. So there's going to be a reference standard or measurement standard in there. There will also be a requirement to document that as well. A calibration process is all the steps and activities that we use to actually execute and perform a calibration, plan it, manage it, perform it. Also, there's a documentation component in there that's going to typically require an electronic database, some software, and maybe even documenting calibrators. So the calibration system is we've got the processes that we've defined, we've got the people and their defined job responsibilities, and now we integrate the tools that they need to actually do their jobs and execute the calibrations. So a calibration system implementation is where we're going to take all of these elements in the calibration system and construct them in a way that meets the business requirements. So it's during this process that we have the opportunity to actually refine and further define those components, and it's an opportunity to improve the process, to optimize it, to automate it, to improve it, and to make it better. So why focus on implementation? The technology is really the easy part. This is the ultimate interaction of cold, hard, rigid technology and a living, breathing, dynamic organization. So about 80% of that process, the focus needs to be on the people and the culture. And we don't want to end up with an island here. So we have other functions within the organization that we really need to have input from in order to integrate this successfully into the rest of the enterprise. And failure will carry a cost. So we're committing resources, corporate resources, and there are risks at every turn. And particularly the novelty of a calibration system. A lot of the customers BMEX works with are doing these projects for the very first time, and then and of itself is a huge risk. But with a proper project approach, these risks you can anticipate them and manage them. So these are 6 pitfalls that we've kind of highlighted. These are the most common, so let's just get right into them. The features and functions arms race. This is where you're going to accumulate all of your requirements, you put it into a feature and function matrix, and then you're going to shop it to potential suppliers, and the one that can check off the most boxes wins. So what this does is it forces us to focus on features and not really on the business objectives that we're trying to achieve here. So we're leaving a lot on the table. So a lot of the focus needs to be on the clarity, and a lot of the risk, rather, is on the clarity and the relevance of the features and functions. So you could have some very complex functions that you need to satisfy, and the way that you put together the features and functions, you could have 2 suppliers that meet that requirement, but the way that the features and functions are put together, one can check off the boxes and the other one can't. Also, those complex capabilities are rather hard to put into a feature and function matrix, so you may have some that are overlooked altogether. You could also have a very complex end-to-end type of multi-step process requirement, and a supplier could mark off all of the boxes that he meets the features, but you find out later that he doesn't actually satisfy your business requirements, so you could end up with an inferior solution. Another risk is that one person probably knows exactly how to interpret the feature, and that's the person who wrote it. So there's multiple interpretations from different people, and also a complete misinterpretation of your features and functions. Also, our vendor responses could differ widely from reality. So you could have a supplier that is very liberal and can mark off a lot of boxes in an effort to make your short list. And you could have a vendor that is a little bit more conservative and can actually satisfy a business requirement, but through his existing features, but doesn't really check off the right boxes. So you kind of end up with a comparison of apples to oranges. So the way that we mitigate this, it's really in the process. So first we want to define our objectives. What are we trying to achieve here? And then also a strategy for meeting those objectives. So we want to define how a new process needs to support our business, And this is really going to lead to a gap analysis, so we can focus on the areas that we need to improve performance. And this is also going to provide a framework for evaluating our possible solutions and our suppliers. So, and also, the one positive with a feature and function is that you do get the opportunity to do your due diligence to make sure that a supplier has the capability to support the project, he has the experience and the approach to support the project. Another pitfall, unclear target and purpose. And this is typically when we are focused so much on delivering the project that we miss the boat on what are we trying to achieve here. So we're going to miss an opportunity to create real business value here by focusing on features and functions. This is very common with the features and functions approach. So the top management is critical here. So he has to give, that sponsor, top management has to give clarity to the rest of the organization. So if he isn't clear on what the objectives here, nobody else is going to be clear. And what that does is that opens the door for the project manager on down to make assumptions. And what if those assumptions are wrong? It's a huge risk. So what we want to do is establish some metrics. Make it better is not a goal. What does better look like? And how do we know when we've achieved it? So putting some metrics, some quantitative and qualitative metrics around, hey, where is success, and how do we know when we achieve it, will be able to drive the rest of the project from beginning to end. Another pitfall, and this is actually very common, and it's easy to fall into. This is the poor man's approach. There's really minimal process engineering, design, business analysis required. You just replicate the legacy system as it is today. So it's really indicative of budget constraints or technological necessity where you have outdated technology and and IT is no longer supporting it, or you're implementing an ERP system and you just, let's just get her done and replicate the system in the new system. And it's also just a lack of vision could be very indicative of this approach. So what we want to do is we want to improve from current state. We want to think more about objectives and less about process. So we want to look at evaluate each one of our requirements and determine is this driven by process or result. So if it's driven by, well, that's the way we've always done it, throw it out and rewrite it with a focus on goals and objectives. So we need to think outside the box here. It's very critical that the process is going to have to change to realize improvement. If we're committing resources and we just replicate the existing system, it's going to be virtually impossible to really realize any ROI on the expenditure. And the fit gap analysis is we want to document the existing system. We don't want to just throw it out. Document the existing system, and we'll be able to do a fit gap analysis and ensure that requirements are met. Failing to gain user and stakeholder adoption. This can be critical to a project. If you build it first and implement it, it will be very hard for people to be committed to it, and they may even be hostile to it. So a prerequisite here is to sit down with all of the stakeholders in the process, and this people from quality, IT, the process experts, the SMEs, the people who intimately know the processes, and sit down and document what they do, what their jobs are. And what you're doing in this process is you're getting them involved from a very early stage. And again, senior management role is critical here. They have to set the priority for the entire project. They have to continually communicate to the project team and to the entire organization that this is a priority and these are our goals. And typically there are multiple sites that will be involved, so having those stakeholders from those sites that expect to take up the solution will be critical as well. The Big Bang implementation. So this is where we're going to switch from using the old system to using the new system on a fixed, predefined date, on a single date. And these are very common in IT projects from years ago. And since IT is likely to own this project, it is very likely that we may see this approach. It is extremely risky. So we're on a fixed time schedule, on one date in the future. What if there's one part of the project that's not ready for it? Or on the go live, if there's an incorrect data set used. The system may get stuck on go live, and just due to inexperience or just startup issues. And particularly if there's not a capable fallback method, it's a huge risk. Also, in these processes, it usually gets down to crunch time, and the user learning and training usually gets shorted in these projects. So all the successful projects that BMEX has been involved in has used a gradual rollout approach to implementation. So this is where we plan and schedule the deployment and the implementations, but we pick one proof of concept site. And this site we will plan and implement and put into production the system. And this is going to show value. This is going to establish credibility with the system. It's going to provide visibility to the other sites and get their input as well. So we need to pick a good proof of concept site. We don't want a major nerve center. We want a site that doesn't have a lot of politics, a site that is open to change and has a good, strong stakeholder to lead that site through that change. And again, we need these sites, this proof of concept site involved from the very beginning. And our last one, under-resourcing and lack of project organization, critical. So this is really a collaboration between a customer, a supplier, and possibly a third party. And most of the resources will be allocated by the customer. So it's a huge commitment on the customer's part. The executive sponsor is super critical in these projects. So they're going to bring the authority to bring these functional managers together when required. That executive sponsor also typically is going to be the one to get funding for the project and top management support behind it. As well as in a multi-site rollout, they have to have the authority to motivate those sites. So you must have a very defined project organization and a project manager, most likely appointed by the customer site. So just to wrap up, and some key takeaways here is that to improve, we have got to change our processes. That is how you realize improvement, streamlined, optimized, automated, is to change the process. So let's focus on our goals of the business. What's going to make it better? Model the process after those goals. And so stay away from that feature and function approach. It will not serve you well. Identifying and getting the stakeholders involved from a very early process, it gives everybody a sense of ownership and will make the entire project go much smoother. Proof of concept model, this will have small successes along the way as opposed to the big bang project. So look at those proof of concept sites from the very beginning. It is resource intensive up front. We need to gauge what we're going to need, what the resources requirements will be, and so that we can get this appropriately resourced. Again, strong executive sponsor is critical in these. Without a strong sponsor, the project has a very high probability of being a failure. So I will turn it over to Pekka Videnoja. He is our professional services manager for BMEX. He will go into a little bit more detail of a process implementation project. Pekka?
Great, thank you, Chuck. And now we are actually going to discuss about the implementing and the process of implementing calibration system. And first of all, let's see what is the content of this part of the presentation. There is a few opening words, and then there is an actual system implementation process. So, the opening words. So it's good to remember and to understand that the calibration system implementation is a process. To succeed and avoid failure, you need to understand the following. There is a large number of interrelated tasks that needs to be carried out in an appropriate sequence. Every step is important, and a decision needs to be made throughout the process. And utilizing the proven implementation model helps a lot. And the steps are overseen by the project manager, and the process requires involvement of the several professionals. The thing that typically causes problems, like a scope creep, budget and schedule overrun, is poor planning and inadequate resourcing, rather than the individual steps which might be too difficult. So, the actual process. The recognizing the challenges and the opportunities. First of all, why you are considering to update your calibration system and the calibration process? The system change process is usually ignited by the recognition of the weaknesses and or opportunities. Nevertheless, what is the reason why? All those reasons are equally important, and the most important part here is that you need to define, because later in the process you need to get back that why we are doing this, and then of course in the end result you need to evaluate what was the outcome, and then you need to know again that why we were doing this in the beginning, and of course to be able to do that you need to document that properly. So define and document reasons why. So now we are jumping actually into the process itself. As the time goes, the first and the most crucial step in every project is the initiation. So the starting up, the building up the process itself. And the process, you need to define that, okay, this is not just the technical part, but the process, that what we try to do here, and what is the actual, what kind of process we are defining now. And then the third step is the actual specification. Here we jump into the step where everything is defined, and then here the key part is to have a common understanding. We are going to go these steps more carefully through in the next slides, but then there is an execution. The project itself is initiated, the process is defined, everything is specified, and now is the actual execution part. So we implement what we have defined, and then deployment, when we take the system in use. And the last but not least is then the actual operation part, which takes hopefully more than 5 to 10 years to operate the actual system. So everything is up and running, and the system is in the maintenance phase and an actual operation. Okay, now let's jump more detailed into these steps. First of all, the initiation, the purpose. It's simply the common target for the project. And then you need to define what are the parties' roles. Both parties, supplier and the customer, has roles. Those tasks need to be defined, because the implementation project itself is a cooperation by nature. So both need to have a common goal and common roles, or their own roles. And of course, the very key role here is that the project team, management and the steering group, contact persons, project managers, their tasks and duties, as well as the decision-making authorities are defined. And of course, every process and every project has changes along when the project goes, but the change management, the mechanism for making and accepting changes during the project needs to be defined already in the beginning. And of course, the testing and acceptance, how we verify that, okay, what is specified and done, how we verify and accept everything. So that's the key part, that needs to be defined already in the beginning. And then there is always some kind of presumptions and limitations, as well as project risks, that there is an assumption and there is a limitation. We are not going to do everything among these projects. So those limitations needs to be clearly defined in the beginning. And then in the initiation phase, what kind of deliverables there are? There are agreements, there is a project plans, scope of work, project reporting tasks, and templates. And this is still the part where the account owner from the vendor side and the project manager has a very high involvement risk. And now the contribution for the project is in a very high level, and we are talking about that. Is this something what is done in the like a daily work? But in this part of the project, the account owner, this is for this project, it's his main task for the daily work. And then also in the customer side, the executive sponsor and the system owner and the project manager has a very high contribution in this phase, rather than the subject matter experts. Still, they are in a minor role in this initiation phase. Okay, then comes the process blueprinting. It's an important but also demanding phase. It's all about the defining the work procedure, not about the naming the tools and brands to use. So you need to define and document what is the existing process, because otherwise it's rather difficult or even totally impossible to develop something if we don't know where we are now. And then, of course, the defining the target to be, where we want to go. And the roadmap is then defined between those two things. So you cannot jump into the new process if you haven't defined that. And this requires a significant customer resources and contribution, as input is gathered from the users and other cross-functional subject matter experts, for example, IT, compliance, and quality. And these connections must also be documented in the process blueprint. And here is very key thing to remember in this second phase, that and here we need to have a very clear answer that, are you willing to adapt a new calibration process? So like Chuck said, that if you want to take a new system in use, but you want to use the old process, it will not be a success. So here you need to answer that you need to be ready and you need to be willing to adapt a new calibration process. And also, it's good to remember that in this stage we haven't yet chose anything. So if you are not ready and you are not willing, then the projects can still be cancelled after this phase. So and also in some cases there has been that, okay, we don't need a calibration system. We first need to have a maintenance system. So rather than just jumping into the calibration system, let's put the maintenance system as a general first in place, and then when that's done, then let's go to the calibration system. But okay, now the process is defined, and then let's start the actual specification. And it is the basis is set in the process blueprinting phase. And it's important to ensure that both the vendor and the customer understands the technical specification and the functionality descriptions in the same manner. Otherwise, the parties will have a different expectation for desired outcome. So, common understanding is very key role. And also the document. Documents require approval from the both parties. And they should be integrated as a part of the contractual documentations and the changes to specifications requires a mutual approval. So that's why we have a change management in place. And here is that the common mistake is that we typically want to jump immediately into this specification phase, and we don't know what kind of process we are trying to follow. So the common mistake is to start the whole process from this point. And here you can see that now there's subject matter experts in both sides, in the vendor side and in customer side. They have a very high role, and the project manager is more about the controlling and keeping the strings together, and the account owner and the executive sponsor has a low role in this phase. And then everything is specified, starts the execution. And actually, if the three first phases, initiation, process blueprinting, and specification, are done well, this is a very easy part. The execution, that we just execute the plans, what was done in the previous phases. And here the more and the biggest focus is in the vendor activities, and also proof of concept implementation should be considered also in this stage, that in multi-site rollouts. And here the surprisingly common mistake is to entering from the order phase into this phase, that okay, let's start doing something. And the common mistake here is also that once we do something, then let's specify in the same way. So that will not lead into the good and then the desired end result. Okay, now we assume that everything is executed as planned and everything is ready. Comes the most interesting part, the deployment. And here is first, this is good to remember that in this part, that the launch event, that even though that you are rolling the solution into your own site where the whole 4 previous stages were executed, still you need to remember that there are people who hasn't seen the system or who hasn't even got a clue what we are doing. So the launch event, the process, the new process and the system must be sold all over again to the new people and the stakeholder, even though that they have been in some part, but the launch event, and then actual the system delivery, equipment, documentation, and associate training, as well as customers' acceptance for the delivery is done, and of course the user training. That is very key part to train people properly, and that is done in the deployment phase. And also the SOPs, work instructions, and the process description must be finalized. And they should be available and will prepare to ensure that the new system will be taken into the use efficiently. And also remember that the new tools means the new process as well. So to highlight that. And also what happens here is that the supply process and the supply project itself will no longer be working, and the work is transferred from the project team to the operational team. So the maintenance phase is starting from here. And then the last part is then the actual operation. And now the system is in use and expected benefits are realized, assuming that the project model has been followed strictly in the implementation. and the system is transferred to maintenance, and the support phase support agreements becomes effective. And now the supply agreement expires, and the change orders and additional orders related to the system. So maybe in the future there is some enhancements and that kind of stuff. So these are like a typical maintenance task. And also here, what is good to remember that now from the vendor resources point of view, we have a support team in the standby mode that they are there to help when there is problems. And then also in the customer side, the executive sponsor has a medium role in here, and the system owner now owns and runs the system. And then there need to be a support organization, and that is built in the deployment phase, and now it is fully in use. And here is good to remember that from the support organization point of view that we have now defined a process and the business process, and then there is an IT process in the background. So the both parties need to have a support organization, the business and the IT. Most probably, if the system is not available, new system is not available, then the IT support organization can help you. But if there is a problem that the users don't know how to use system, or they see a new functionality, what they don't remember how the training was held for that particular part, then the business support organization needs to take in place, because most probably the IT people cannot help in that matter, that they don't know how the system is used actually in the production. So there needs to be both sides need to have their own support organization. And then, as a last part, there is this: what are the key roles in every different stages in this process? The initiation, the purpose is all about the purpose and the scope of the project, as well as has a common understanding of the roles which both has, and the managing and the building up the team, and the process blueprint, the re-engineering the calibration process, fit gap analysis, how well the new system will fulfill all our requirements, and of course the cross-functional requirements, calibration and maintenance requirements, asset management, IT and compliance, everything, all the cross connections are built in the process blueprinting phase. And then the specification, user requirement specification, function. So what we actually want, what is wanted from the system itself, and how we understand that the system is working. So the functional design specification, as well as configuration specification and the test specification, how the system is tested. And then the execution. There is a system configurations, and of course the data migration. That is a key part in the execution phase. If there is an integration in place, that is set up, and the verification and the validation of the done configuration, testing for that, and the SOPs and work instructions. And the deployment. We take now the system in use. We sold it again. We deliver the system. We install everything. We accepted it. We had a technical trainings and switch from the project organization to the operative organization. And then the go live. That's the key role in here. Let's do the go live. And then the last part, the operational. The benefits are realized. Everybody are happy. We follow the process, and people buy the new system and they are happy, and everybody are happy, and the maintenance and support is rolling from now on, and the next few years, hopefully many years in the future. So that's basically the whole implementation process, and that was end of my part. Thank you.
Okay, thank you, Chuck and Pekka. Okay, we'd now like to move into our first Q&A session. We've already received some great questions, and I want to encourage everyone to join into the discussion by entering any questions you have into that Q&A box on the bottom right-hand corner of your screen. And remember, if we don't get to your question, we will save it until our final Q&A. Now, I'd like everyone to double-click on the video feed so that you will open up into a full screen mode and be able to view all of our presenters today to have a panelist feel for the Q&A session. Okay, just jumping right into it. What justification is there to get a project started?
Well, Stacy, I'll take that one. This is Chuck. You know, there's a lot of ways to improve a project or improve a process. If you can increase the level of automation, which would improve your efficiency. You can integrate it with the rest of the enterprise and streamline all those other back office processes and make the overall process simpler. And you can, if you want to put together a solution that can realize some economies of scale, so you have a complete solution for multiple sites, you can harmonize those programs across those sites, and so everybody's working the same way, same methods. So there's any number of improved compliance with streamlined documentation. So there's a lot of different ways you can justify a project. Typically, to build a business case, that we would engage in that gap analysis. So you have a general idea of what you want to do. You have a general idea of maybe some possible solutions, but that gap analysis is going to be a real easy tool to use to identify identify where your current state is and where your future state is that you want to reach. So and also the tasks that you need to accomplish that. So in a gap analysis, the first thing you will do is identify your future state. So identify what objectives do you have. So it could be I want to reduce the time it takes to do a pressure transmitter calibration by 20%. Very easy, quantifiable. And then you want to analyze your current situation. So this is going to be, you know, what do I need to do that? Who knows how to do this? Who knows the current process? Who has a good picture of what we're doing now? What's the best way to get this information? So an example would be to calibrate a pressure transmitter right now from beginning to end takes 2 hours. So that's our current state, our current situation. Then we want to identify where we can bridge that gap, and that's going to tell us what we need to accomplish our task. So this is going to be, create to realize that 20% decrease. We want a single database where all of our information is readily available, and we want to reduce the number of tools that the technician has to handle, and eliminate the data entry component of the documentation. So that the gap analysis is where you would justify and get these projects started, and then you can take your gap analysis and present it to a sponsor. And you want to make sure you don't don't overwhelm them with details, but give them enough details to understand and get some sponsorship and take it from there. But that gap analysis is a very good, easy tool to use to do that. Stacy, I didn't know you were there.
Sorry about that. I muted myself, sorry. Okay, our next question is regarding the Big Bang implementation. How is the implementation managed on the proof of concept sites?
Stacy, I can take that one. So basically, in the proof of concept is something in the versus the Big Bang implementation is that we collect as much as the requirements from the different sites as we can, and then we select one of the sites as a proof of concept site. That okay, there we do, and there we implement the process, and they implement the new system as a common system just for one site, and streamline the process in there, and then go through everything, and then we need to have after the proof of concept or during that process we need to have a rollout plan that okay, how the rest of the sites are getting along. So it's basically first of all the process part and the specification part that we listen everybody and take the common understanding and try that in one site. And if that is proven to be working, then of course during that phase we can streamline the process and streamline the system, and then we go to the next site, because we already know that is working for the one site, and everybody was giving their own contribution when the specification was done. So it's from the managing point of view, it's a little bit challenging, but still doable.
Okay, we have a follow-up question on this. Now, to reword it a little bit, does the Big Bang methodology still apply if you stop using System A on day 1 and start using System B on day 2?
Can you repeat the question?
To reword the previous question, it's regarding the proof of concept sites. Does the Big Bang methodology still apply if you stop using System A on day 1 and you start using a System B on day 2?
Yeah, that is of course something in this methodology. The Big Bang was more about if we are talking about multi-sites rather than one site. Well, of course, that is something what we need to plan carefully. That how the legacy system is put it aside, and that the new system is taken in use. So it's all about the deployment phase where we do the switching from the legacy system into the new system, and how the differences and how the transfer phase is managed. So rather than to have a one day when legacy system stops and the new system is taken in place, we do like a smooth operation that let's concentrate on different units or different buildings or something like that. That okay, we don't stop everything in one day and start new system in the next day. So it's all about the planning, how the transition is done.
Okay, and then we just have one last question to wrap up this first Q&A. Have any of you guys been involved in a project where current data needed to be migrated to a new system using an automated or validated process, and how did you manage this process?
Okay, at least I can answer in there. There are different methods how this can be managed. That of course we need to understand that the data itself and the system. So there are different places where the system or the data itself can be validated. It can be validated maybe in that phase when the data is collected and the cleansed in the middle, or it can be validated when it is entered into the new system. So we need to also to define the process how the data validation is handled when it is moved from the legacy system to the new system. And there are several ways how it can be done, but that is also something what needs to be taken in account when the process blueprinting is done, that how we manage the data when it is needed to be validated also in the new system.
Okay, great. Well, these have been some great questions, and we will have some more at the very end of today's presentation. And at this point, I would like to hand things over to Jody.
Okay, the Salt River Project, main businesses is agriculture improvement and the power district. Power generation combines hydro, gas turbine, coal-fired, solar, and wind generation. Water includes an extensive system of reservoirs, wells, canals, and irrigation laterals. We have approximately 1 million customers, 5,000 employees. Power generation, transmission, and distribution covers approximately 2,900 square mile service area. And the water transmission distribution covers approximately 375 service area miles. So what I'm going to be discussing is increasing our probability for a successful implementation. So this is critical to any of the projects and extremely critical to the project that I'm going to be showing you today. The discussion points will be, I'm going to show you one of the sites, SRP calibration history, where we started and where we are today. Selection of the vendor and the software, what that process was. Project team formation, operation, and decision making. Responsibilities of the vendor and the customer. The procurement process. Documentation, project update, and go live experience. So back in 1974, a 3-unit, 800 megawatt supercritical generating station went live with the first unit. And this is an example of the documentation that we had at the time, which was a very good quality system for its day. It was paper cards and manuals with calibration information included in them. Some of the issues that we encountered with this process are lost data, no data security, no reporting, and no audit trail. As a technician at this time, I was given the assignment to go through a system audit with one of our state inspectors. And a couple of these cards were misplaced in the wrong area. And so we had to try to explain to the state inspector why we didn't have these cards readily available. It was a very discomforting place to be when you're right in the middle of an audit. So the next thing that we did in the early 90s is I had the opportunity to be the lead of a project to get all of our data entered into an electronic Excel database. So this was a fairly large undertaking. We've hired some temporary help for data entry, but we got all of our information, our entire database, into one Excel spreadsheet. And during that process, we also were able to go through some validation against all of the information that we had. Some of the data that was in the hard copies of the books has been changed over time, and that was documented on the cards. So we still encountered lost data, no reporting, no audit trail, and it was a new process. So in the late 90s, this site went through an extensive control system upgrade into a new DCS system. They had a lot of pneumatics, so all of that stuff was upgraded. In that process, we were able to document all of our instrument data for the control system, everything that was hardwired into the I/O, which gave us an opportunity to capture data that we had never had before. So we built Access application with the help of a process analyst, which in this project was our first experience working with IT in these type of projects. And it was a great experience because it allowed us to learn more about how these processes were on the IT side, and our process analysts took the time to learn the business, which is critical. So some of the accomplishments of this project were secured data. We were able to report off of Calibration. We wrote a lot of hard copy reports. We had state certified audit reports, so now we could just give the auditor a report and it would show him when the instruments were calibrated. So this really solved all of our audit issues. Linked to drawings, so this system was also linked to our SIMAGE documentation system. We documented all of our DCS points. We did start the BMEX process around this time. I went to a ISA conference where did a presentation on this particular software program. It was the first time that we had did a presentation, and I met the BMEX representative, took it back to our site, and they chose to use the system. So we started using BMEX. It was not integrated with any system. It was standalone. So issues encountered. This was a difficult process. It took a long time to do, but it was a good experience. It was costly, and when you got to the end of the project, ongoing support was a challenge, as on the IT side, positions transitioned and they moved to other things. It was very critical that you understand how this system was built. So in 2008, there was a push in the business to get rid of standalone software applications. And so we got an approved project to take our Access program and build it into Maximo 5.2, which was our work management system at the time. So this was a customized project that we underwent. It was a difficult project, but one that we were able to replicate most of the features we had in Access. So some of the accomplishments that we had during this project is the data was secured, calibration reporting, state audit reports, linked to drawings, documented DCS points. Asset data comparison was a new one that we had built in Maximo 7.5, and that was in 2012. So what we did is we took a download from our DCS system, compared it to Maximo, and so it tells us our discrepancies if anything changes in the DCS system or in the Maximo system, so it keeps those systems in sync. adopted a governance process so we can support the system, and then also implemented a meter data process to drive PMs off the instrument data. Some of the issues that we encountered, difficult process, it's very costly, and the same ongoing support after the fact once the program is up and running. Now we're going to talk a little bit about the BMEX Maximo integrated project. So in 2005, we did purchase the standalone BMEX application. The technicians really liked the system. It was very user-friendly and provided a lot of information that we didn't have before. At that time, it was not integrated to Maximo. In 2012, we went through the process of pushing our calibration to Maximo 7.5, which was an out-of-the-box calibration support system. At the time, the plan was to go with Cyclo for the mobile process and use Maximo 7.5 for calibration. The guys did try Maximo calibration. They didn't like it compared to the BMEX. And so the business is, the guys in the field are actually the ones that pushed to get BMEX integrated to Maximo. So through the approval process, when we did our last upgrade, it included the BMEX project that I'm going to show you through this. So our project team included myself as the technical lead. We had a business process analyst that was extremely detailed, did a great job, built a lot of documentation for us. So that position is very critical. The integration team was a SRP team that did a great job, worked with the Maximo developers and the BMEX developers to make sure that all of our needs were met. We had a very good quality experienced site manager locally at the site that sponsored the project. The Maximo team, we had 2 developers on the Maximo side that I had worked with through the entire upgrade into Maximo 7.5 and the upgrade into SAP. And so I was very familiar and had a lot of trust with those guys. We had a SME, which was instrument tech with 35 years of experience, very good quality technician that I'd worked with for many years. I had an IT manager that I'd worked with all the way through our projects. So this project team was a team that I could trust, and in doing so, we didn't really have a lot of uncovered issues going forward into the project. Responsibilities of the vendor and customer. So on the business side, we were responsible for our business processes, documenting those, the budget, data, requirements, and testing. Just to address one of the questions that came up earlier on the data. So we've been cleaning up data since 1974, and you know, it's an ongoing process. It takes a lot of time and effort, and it's something that can go south on you in a very short period of time if it's not continually monitored. So during the Maximo process, we had the opportunity to clean up data. During the process going to BMEX, we also cleaned up data. So going into the BMEX process, we felt very comfortable with the data that we had because we had spent many, many hours cleaning it up. On the CMX side, they were extremely beneficial as we went through the process, making sure that we understood the new calibration process and how it would be related to Maximo. The data conversion, they worked hand in hand with our technician. They went back and forth to make sure all the templates were right and the data was in the right format. And then integration support through the process. They did a good job supporting our integration team when we had run into issues. On the Maximo side, we relied heavily on our Maximo developers to extract the data sheets that we had in Maximo, and then any of the Maximo code that was used to integrate with the new system. The integration team, main responsibilities were file transfer to and from the CMX and Maximo. The procurement process, so one of the responsibilities that I had was I was responsible for the Maximo upgrade from the business, and so the manager came to me and asked me, said the guys requested that we look at using BMX integrated with Maximo for our calibration process. And so what he wanted me to do is analyze the system enough to be able to tell him that the system could either work and be successful or it couldn't. If I came back and said that it could, then it better work. If I said that it couldn't, then we didn't do it. So I relied heavily on our Maximo developers team, our IT managers, to get their input working with the CMX developers to make sure everybody had a good understanding of what the system was going to be in the future. Once we did that, the scope document and approval, process, design, preparation, and planning, and project implementation. Pretty much after we went through the first step was pretty standard. So just some examples of documentation during this project. Scope document, design, process, requirements, testing, reporting. A couple of the key ones that were very critical to this project, I think, was the design and the process. Our process analyst did a great job in helping us document what the process to be was going to be and what it looked like. And I used that many, many times as we were going through our different installation phases to make sure that we were on the right track and we were getting what we needed. So that was extremely beneficial. The testing process, our SME, our technician, and our process analyst built the tests in a system that we use for testing all of our software for Maximo upgrades and SAP, where we can go in and actually track what passes and what fails. That was extremely beneficial to me to get a confidence level that when we go live with this new system, that it's going to work. So that's very important. And then the reporting, documenting all the reporting and monitoring the reports as our process analysts release those during the project. So the actual upgrade, project upgrade, this is going to be the nuts and bolts of the whole thing, and it's actually extremely simple when you think of how complicated it could be. But in Maximo, we have assets, and we have regular instrument assets of instruments that are not ever calibrated. For example, an orifice would fall under that category. And then we have calibrated assets. So in order to meet the criteria to be transferred to the CMX software, we had to have an asset that was type INC for instrument and control, a calibration checked, and then a work type of cal, so a work order that is identified as a calibration work order. That calibration checked is what CMX worked with our technician on, and so we have roughly 28,000 instruments, and 7,700 of them is what transfers over to CMX. So if you write a work order on an instrument that is not a calibrated instrument, it does not go to CMX. If you write a work order on a, say, transmitter, and it meets that criteria, then it automatically flows to the CMX software. That's extremely critical, because now in the process we have a built-in method of security that doesn't allow a bunch of garbage to come over to the CMX software. This is extremely critical. So if somebody writes a work order on an instrument and they write it against the system header, it's not going to go anywhere. So this is very important. It's going to give us good data integrity as we go forward. So once you meet that criteria, either a standalone work order or PM work orders, routes, can be transferred over to CMX. If you're in an outage, planning for an outage, and let's say that you have 2,000 PM work orders on assets that you need calibrated, once they go through and plan those and they approve them, it's going to meet all of the criteria for Maximo to go through the integration and into CMX. They're going to go into the CMX software. The technician will be able to see them, be able to organize them, and then as the work orders come through for these to be calibrated, they will download all of those assets to Maximo, or to the CMX calibrator. They'll go out and calibrate them, and they'll either pass or fail. They'll come back, download them back into the CMX software, and when they pass, they will automatically be sent back to Maximo with the unique work order number and the unique asset ID, and it will automatically complete the work order with the person's name, date, and default text that we've put in there for that process. So that is extremely important to understanding this process. So some of the key things, our technicians now do not touch the CMS calibration data entry. So they no longer have to come back to Maximo and say, as found, as left, and do all that process. Complete the work order. All that's done automatically. So you figure a couple thousand work orders during an outage, that's a lot of man hours. The Maximo is the asset system of record. It tracks the assets. All it cares about is if it had a calibration and is it passed. If it failed, the work order doesn't go to complete, the technician has to address it. The CMX is the calibration system of record. If you need details of the calibration, CMX is the place to go. That's where you're going to be able to prove what the calibration actually was, and we've been able to do that many times. So field personnel don't touch the work orders. That's really the return on investment for this whole entire process. It saves time and it saves money. So failure is not an option. During our experience with many different implementations of software, we've been able to upgrade Maximo, upgrade SAP, and a failed project is extremely costly and can be crippling to the business. So We have gotten a lot of experience and worked with IT enough that we've figured out the things that you need to do to be successful. So the lessons learned, what did we do to be successful? So the data integrity is very critical. In this system, your calibration data that you determined and are configuring CMX with needs to be accurate, it needs to be right. So that's a very critical process in this step. Building a solid team. I can't stress enough how much I trust the team that we had and their abilities in their individual jobs. Set realistic timelines. So that is very critical to give yourself enough time to be successful. Don't back yourself up into a corner and have no way out. The interpretation is one that I've learned many lessons on, and that is, as I've worked with developers in Maximo and CMX and other projects, it's very important that you understand that the business requirements that the business has are the same as what the developers are hearing them say. Because a lot of times, the business will say, I want an apple cut in 6 different pieces, and the developer will hear that as, I want a watermelon cut in half. And you can run into a lot of problems if they don't fully understand the requirements up front. So during this whole entire process, I would work with the developers on a daily basis and sit down with them as they were developing to make sure that they understood exactly how the business was operating. And that has been very successful through all of our projects. We've got a very good relationship with IT developers. Document business processes. That's very, very important to be able to have that documentation, not only during the project, but after the project when you finish, because any type of changes is where you're going to go to that document to update it. A good governance process is critical to manage the project going forward. And then make sure that people understand what we need to support the new process. What is it going to take on the IT side? What is it going to take on the business side? Both of those are extremely critical. Stacy, back to you. Any questions?
Thanks, Jody. All right. We have some great questions already submitted into our second Q&A. Pull those right up. Is CMX migration available without BMX conversion, as if Maximo already exists? Hello?
Hey, Pekka, can you draw on your past experience to answer that one?
Stacy, can you repeat the question?
Sure. Is CMX migration available without BMX conversion if Maximo exists already?
If I understood correctly, then I can answer that. Sorry, but I did not fully understand the question, so I'm not able to answer.
I can take this one, I think, Pekka. This is Jody. So
okay.
The way I read that question is, can CMX work without an integration with Maximo or a work management system? And yeah, we used CMX standalone without integration. It's a standalone database. but you don't have any integration to your work management system if you do it that way.
Okay. Does the system recognize the difference between a digital instrument, as in switch equals functional check, and an analog instrument, as in calibration?
Yeah, those functional templates are all set up, and actually Pekka and our instrument technicians spent a lot of time making sure we had the right functional template for the right instrument. Anything else on that one, Pekka?
No, I think that was basically all what needs to be done, said for that.
Okay. Did you need a specialist programmer in Maximo's and BMAX to integrate both programs to work them?
We had developers, Maximo developers, and we also had integration developers, two separate teams on the business side. And then CMX had their developers on their side that helped us with the formatting of the data and integration and making sure the system on the CMX side was set up and mapped properly. But we did make some changes on the Maximo side.
Yeah, and actually in the CMX side, we did not need to do actual implementation work. So in our case, only the configuration was enough what we did for the integration interface.
Okay, great. How did you train the instrument techs to use the new calibration process?
So they were already using CMX for that site. One of the things that they did is our process analyst and the lead technician built very user-friendly user guides, and they are in the process now of releasing those and training the technicians. They ended up being extremely high quality and very easy to understand for the guys.
Okay. If your I'm not sure I fully understand this question. It just says, calibration report has no data entries, as found or as left numbers. Is that correct?
So our the calibration, like on an analog instrument, records the actual calibration. So you don't have to go as found, as left, as in we had to do in Maximo where we did a 5-point calibration.
Have you tried a mobility solutions, as in smartphone or tablet, for CMX and or Maximo?
On the Maximo side, we're in the process now of looking at different mobility options, but so far we haven't implemented that.
Okay. How many instrument assets versus calibration assets are in Maximo?
So in Maximo, we have roughly 28,000 instrument assets, and 7,700 of those were identified as calibrated assets. An example is your transmitters, pressure switches, anything that you would have to calibrate or do a functional check on, level controllers, valve calibrations.
Okay. Can you describe the data migration process from Maximo into CMX? Was it manual entry, or is it possible to perform a data import?
So in Maximo, the system is configured so if they build a new asset, now that we have everything integrated and synchronized, let's say they do a project or they build a new asset, our instrument administrator in Maximo is the same security and same resources as the CMX administrator. So they would go in and build the asset in Maximo, and then that's automatically integrated over to CMX, and it says, hey, you got a new asset in Maximo, now you need to link it up over in the CMX side and make sure all the data points are filled out properly. And it also has email notifications as it goes through all of those different processes.
Okay, great. Let's see. All right, going back to the earlier part of today's webinar, can you outline a gap analysis?
Yeah, Stacy, I think I may have answered that already, but it's a very simple tool and easy to use to be able to identify your future state, where you want to be, what improvements you want to make, document where you are now, and then you'll be able to easily identify what you need to do to get there. And that can drive that'll develop your business case and enable you to go and secure a sponsor. So there's several steps, very easy tool to use. So it can start the whole process.
Okay. What's the most common mistake people make when defining the specifications for a new system?
On the business.
I think that.
Go ahead.
Jody, please go ahead.
Jody, since you have experience, why don't you take that one?
Okay.
Yeah.
So some of the issues on the business side that we run into is it's difficult to sit people down in a room and start thinking through the process of what you want. What do you want the system to be so we can write an accurate spec and don't have surprises in the future? So that's one of the things that we've been very fortunate to have some extremely good process analysts that will sit down in a room with us and we'll start documenting our future to be processed and start asking questions that normally the regular business guys don't think of. And so it really starts you going through that path. So it helps you build a spec that reduces the surprises down the road.
Okay, great. Well, these have been some great questions, and I just want to thank everyone who participated today, and actually all of you who attended. We want to thank you as well. If you missed any point of this webinar, or if you'd like to watch the recorded version, be on the lookout for an email from me within the next couple of days with a direct link to that recording, as well as additional links for supporting information. This concludes the How to Avoid Pitfalls of Calibration System Implementation webinar. We thank you for attending, and we sincerely hope you acquired some useful information, and we hope to see you again at one of our future webinars. Have a great day, everyone.